Hello everybody! Today I want to show you an extension from the tutorial from last week about partitioning with PCG, and it will be about hierarchical partitioning, or Hi-Gen for short, from hierarchical generation. So if you have an example graph like I have here, which is adding a lot of detail with a very dense placement of meshes, for example here into this area, if I go to the profiling tab, I can see that my graph is generating 284 megabytes of data, and this is for about 319,000 points. So if I have this graph covering a bigger area, because now it's not covering my full level, not even close to my full level, and it's still generating quarter of a gigabyte of data, you can see that it will generate a huge amount of data, which will be needed to save the position of every of these objects into my game. And if we want to avoid that, we can do the generation of these details entirely on runtime. And we can do it with the Hi-Gen option for PCG. And in order to do this, you need first to select the PCG volume in your game. Like I have here this PCG partition volume, and you need to activate the is partitioned checkbox like we did in the last tutorial. But this time, in addition to this, we'll change the generation trigger to generate at runtime. So you will have nothing in your level until you hit the play button. And actually currently I still don't have anything, and let me show you what's the problem. I clicked Shift and F1 in order to get the access to my mouse while I'm in the game mode. And let's see the output walk right here. If I go to the end of the walk, you see that I have this error. And this error is telling me that the PCG world actor is not set to be serialized. So let me stop the level. And let's go to the PCG world actor into my outliner. And here into the serialization mode, from never serialize, choose always serialize. And now if I hit play, the objects will start appearing around me. And let's change a little bit the settings right now. So another thing you can do from your PCG world actor, so find the PCG world actor in your outliner, and in addition to changing this serialization mode, you can click this treat editor viewport as generation source, and this will make it that the viewport of the editor is treated like your player. So it will generate around the viewport as well. So let's go inside the PCG graph, and let's click somewhere where you don't have any node selected, or click here onto the graph settings button at the top. And we need to click this hierarchical generation button, or Hi-Gen. So let's click it. And this will give you an option on which grid you want to generate the objects that you spawn in your level. So let's change the graph to something smaller in order to see what's happening with this generation mode at runtime. I'll change the default grid size to 400. And let's save and run the game. So when the size is set to 400, you can see that these details are being generated around my player, and they're generated about 800 units around my player. It's the default values are double the size of the generation grid. So for the grid of 400, it's 800 units. So as you can see, about 8 meters away from my player, this generation is not contributing any objects to the level. So here my volume ended, so let's go back into the volume. And by having this Hi-Gen mode, you can control the grid size, the grid partition size that's generating around your player for each of the different type of objects, or each different parts of your graph. And the easiest way to do this is to, in addition to changing the size for the full graph, is to add the change grid size node. And I'll give you an example right now why you want to do this and how it can be beneficial. So I'll disable all the spawning except for these rocks, or not rocks, but brick shaped objects that I have on my ground to break up the repetition of the ground texture and to add a little bit of depth to my level. So this graph is done, just an example by the way. I know it can be done with displacement or any other method, but I just want to have a dense object placement in order to show you how this works. You can imagine this as a grass, for example, or any other type of different small objects that you place in your level, and you don't need to save it in your game because it's not really important for the gameplay. It's just a visual decoration. So this change grid size node can change the partition size to something smaller than your original size. It cannot change it to a larger size. So let's go to a larger size, for example 6400 for the default size, and let's use this change grid size to 400, and let's connect this. And when you use this kind of grid size nodes, the change grid size nodes, it's always a good idea to have an intersection node and to intersect it with the volume of the partition of your new grid. So that way you don't use the points that are outside your grid and you don't take them into consideration where running all the nodes after this grid size node. So this is a pattern you will be probably always using when you're doing the change grid size node, and it's similar to the pitfalls of the partitioning that we looked at into the previous video, where you want to intersect your partition with the points that you're creating in order not to have them duplicated into all the partitions. So make sure that you use this intersection, connect the grid cell volume to the second input of the intersection, and you should be fine. So right now, because these are all the objects that we spawn, it's basically like we had it before when we had the grid size set to 400 for everything. But we can change this, and if I hit an A key to inspect some node, you can see now that we have the Hi-Gen enabled for the graph. It will show you on which grid each node is being executed. So these nodes are being executed in the 64 grid or 64 meters, and these are executed to the 4 meters grid. So if I select some of the nodes that are partition grid actors 400, they are on the 400 grid, you'll see that these nodes become with a solid background and these ones became with a black background, and this means that it's using the cache data from the bigger grid into the smaller grid, but the ones that are with the white background for the particular partition that we have selected into our debug object are the ones that are being executed into the current grid. All the others are providing cache data from the higher grid. And if I do, for example, here a random choice node, and if I choose 0.2 of the objects, and I'll use this into the chosen pin, and I'll use all the other ones here into the 400 grid below. So for the 0.2 of the points, I'll do a transform points, and I'll scale them a little bit bigger from 1.5 to 2, and I'll use the same static mesh spawner that I had before. So in this way, you can see that let's disable this top one and this bottom one. So I have no objects right now. So let's enable the top one. So the top one with the bigger stones is spawning much further away from my player, or currently from my viewport camera, than the one below. And this is because it's executing on the 64 meters grid, and the one below is executing on the 4 meters grid. And in that way, so let's reduce this to 1.25 and 1.5, something like this. So it's not so huge, but in this way, I can have the detail that I want into my distance shots. So when I run into my level, into the distance, I'll see these bigger details, but I don't need to see this further away from my player, all these little rocks that we generate with this additional static mesh spawner here below. Let's enable this change grid size node. Let's go back to some part of the graph which is being executed. And right now, if I inspect this static mesh spawner for this particular partition, there are only 65 entries into this partition. 64 into this one, 73 into this one. So it's split between the partitions that I create around my player. And it doesn't create objects which are too far away from my player. So if I go here next to the edge of my volume and I start to go back, you can see that I have only 2 active partitions at the 400 grid with my static meshes for the small rocks. So in this way, you can control how far away from your player and how much objects are you adding in your level. And you can basically do it in a way that doesn't show a very big pop-in for the objects. For example, I can change this to 800 and let's start enabling, let's disable these 2 nodes and enable the next one. So the next one are some very, very small objects like this on the ground. So I can use the same change grid size pattern like we had before for those. And I can even reduce the size to a smaller grid, 400. I don't need them to show up further away than 8 meters, which is the double of this 400 size. Let's disable this static mesh spawner, enable the next one. So these are some, again, small objects, which I don't really need too far away. But let's say I'll do an 800 grid for them because they are a little bit more noticeable than the other ones. Let's do it for the next one. Let's disable this and enable this. So these objects are clearly bigger, and if I move, it's a very easy to notice pop-in for this big object. So 800 is not enough for this. So let's choose 3200 for this. And I'll move a bit in the level. It seems like it's loading pretty unnoticeable. So it's still noticeable, but when you are playing and you have all the other objects that are spawning here, you will not notice it, I believe. So let's leave it at 3200. And the last one are these little rocks. We can use the smallest grid size for them. They're not too noticeable anyway. And let's enable everything back. Let's save everything and let's hit play in the game. And you can see it's very, very dense PCG graph with a lot of objects and spawning them just around the player saves a tons of resources, and controlling each different type of how much area it should cover around the player is optimizing the performance of the game very good, I believe, because you can see we are clearly over 100 FPS running around. There are constantly areas that are being loaded and unloaded, but the FPS doesn't change. So it's a great way, and this is all running on CPU. You can sample the terrain and spawn everything like this on the GPU as well, and I'll show you this in another tutorial, and it will be even more optimized. When you have spawning on CPU, there is a benefit that you can enable collision. So for example, for these bigger objects into this static mesh spawner, let's scale them a little bit more so they're easier to show you the collision like I want to show you right now. So I'll scale them to 2 times, and let's enable the collision for a couple of the objects. So for this big beam wood, let's put the collision to block all. The ropes don't need collision, but this container, which is this one, let's put collision to this as well. So having the spawner on the CPU like we have it right now has the advantage that you can enable collision. And right now you can see that I can go on top of this beam of wood. I can go on top of this basket. So the collision works perfectly. And I still have over 100 frames per second with this huge amount of objects around me. So there are tens of thousands of objects. And now that I have this setup, I'm not limited on the size of this field because I'm not saving the data into my game and I'm not having all the objects together on my screen as well. So I can scale this to cover the entire area of my level. And let's hit play right now. And you can see that now let's go and play from somewhere that we didn't have this before. Let's say here. We are very far away from the original place that we had this graph. But now this graph is covering the full level. And it doesn't even have problems running. You can see it's very smooth. So this is the power of the Hi-Gen with the runtime generation from PCG. So I hope you like this tutorial. If you like it, click like on the video, subscribe for the channel, and you can join the channel into the higher levels. You can watch these tutorials earlier, ask your questions in the comments, and get your answers before everybody else. And guys, I'll see you in the next tutorial. Bye.